Okay, so here we are with Unit 3 on functions, our introduction to functions. This is Lesson 1 called Graphing Stories. What we're going to learn here is we're going to learn how to look at pictures, different types of graphs, and we're going to be able to kind of tell what's going on in the graph in words. We're going to make stories based on what we see in the pictures. So, for example, if we just want to analyze this first graph here, this shows the volume of air in a balloon as you blow it up until it pops. So we want to determine what the variables are and how the variables are related at different points. So let's just try to take a look at this and try and make sense and translate what's going on in this picture here. So first thing that we notice is down here is time, and over here says volume. So, and we see the number 0 down here and the number 0 here. So the time is increasing going this way, and the volume is increasing going up. So that's important to realize before we get started. So when this question is asking us what are the variables, our variables are these two things. It's time and volume. So the variables are time and volume. They're the two things that are going to vary. They're going to change. So let's start reading into this graph and see what's going on. So that as time increases from here to here, the volume of the balloon increases that much. So in other words, the balloon just got a little bit bigger. Well, that's because I was blowing air in the balloon for a couple seconds. And then I have this flat part here. So time keeps going on. Here's the time. It keeps going on. Another couple seconds pass by. But notice the volume of the balloon stopped increasing. It did not get it didn't get any bigger. So that's probably because the person's taking a breath so that they could once again blow into the balloon and the volume would increase over the next couple seconds. And then they need to take another breath. And then they need to blow into the balloon. And then they take another breath. And then they start to blow into the balloon, and suddenly the volume completely drops off. This piece here. All of a sudden the volume completely drops off, and there's no volume left, and it's almost instantaneous. And that's because the balloon popped. So let's see, how are these two variables related at different points? Well, as time goes on, the more time, the more volume is getting put into the balloon, the more air is getting put into the balloon, until we reach whatever time this is right here when the balloon pops. And that's how these are related. So whenever you see a graph that's in different sections like this, in different pieces, you should always just try to take a look and try to understand what's going on. And notice we could kind of tell the story based on the graph, or we could look at the story itself and make a graph here. Another neat thing about these graphing stories is that we can represent all the data in many different ways. One of the ways is a table. One of the ways is a graph. We'll see soon enough that we can actually write equations also to model some of these, to model the data and model stories. But tables and graphs both show relationships between variables. The data from a table are often displayed using a graph to visually represent the relationships. In other words, the table and the graph are the same exact thing, just in two different ways. So let's look at this question. A band allowed fans to download their new video from their website. The table shows the total number of downloads after 1, 2, 3, and 4 days. Which graph could represent the data shown in the table? So what we want to do is we want to take a look at the information in this table. We want to start to try to correlate the information from the table to these graphs. So the first thing we want to realize is that we have two different categories. We have day and we have video downloads. So let's look at all of these graphs. If you notice, the bottom here is day on every single one of them. So as the days increase, the amount of days increase, okay, from going from left to right. And then we have video downloads going up and down, so it says downloads here. And the downloads are increasing from bottom to top. Okay, so all of our tables are set up correctly. Now what we want to look at is we have 4 pieces of data total. We have at day 1, how many downloads. We have at day 2, how many downloads. Day 3, how many downloads. And day 4, how many downloads. So that's 4 pieces of data. So looking at the 4 different graphs, again, we have 4 pieces of data on each one. If you see, we have these red dots on each one. There's 4 of them. So now the key here is to try and determine which one of these graphs is going to best suit our data. So let's try and visually, let's look at this first graph here, this one. Let's look and see. So if at day 1 we had 346 downloads, so let's just assume, let's just count this as day 1 and this at about 346. So day 2 would have to be here, day 3 would be here, and day 4 would be here. Well, the distance from that point and that point, notice how this distance on each one of these points is about the same every time. So if this was about 346 or 350 or so, then this one would have to be twice that, so this would have to be at 700. But we're supposed to be at 1011. So this might not be the right graph. Let's see. So if we went up another 350, we would be at a little over 1,000 for this third day. Oh yeah, we're way off. This is supposed to be up at almost 3,500. So it's not going to end up being this graph because these points going straight across here are kind of going up in a linear fashion. What I mean by that is I can draw a line straight through these points. And my data is not suggesting that there's a linear model going on here. Let's take a look at this bottom corner one down here. Okay, so at day 1, day 2, day 3, day 4. And so if this is day 1 was 346, well then at day 2, it looks like I have even less downloads, and at day 3 even less downloads than that. And that's not true according to our data. This is also linear. It's just linear going this way. But our data suggests that it's not decreasing. The amount of downloads is increasing. So we're going to have to take a look at these other 2 graphs. It's not this one. So let's look at the top right one here and see if this one works. First thing you can notice here is I have day 1, day 2, day 3, day 4. Those aren't spread out very well, but I think that's kind of my mistake when I made it. Let's look at the data. So 346. If this is 346, here's the points that kind of correlate to these. Let's see. So if this is 346, then this one should be, well, that's about, maybe that did jump to 1,000. So that's a pretty good jump. Now, from here to here needs to go up another 2,500. But I only went up 1,000 in this whole section right here. So is this going to be another 2,500? That doesn't make much sense. If that scale is going to be at all accurate, then that's not going to make any sense. So that's probably not our graph either. So it looks like by process of elimination it's going to be this one, but the bottom left one. Let's just take a look. Day 1, day 2, day 3, day 4. So if this is 346, about 350, then this is about 1,000. Okay, we're close. Let's see, then does the gap get even bigger? It sure does, it gets a lot bigger. And then after that, does the gap get even bigger going up to 10,000? It does. So notice how these jumps from here to here, and then from here to here, notice how these gaps get bigger and bigger and bigger, and so does the amount of DVDs sold going from day 1 to day 2, from day 2 to day 3, and day 3 to day 4. They're getting I don't want to say exponentially, but they are. They're getting much bigger. And whenever you have a situation like that where it's not going up by the same amount, you're going to end up with a curve like this. And if you notice, it's kind of like a ramp or something. So anyway, that's how you kind of take a look at the data, you take a look at a table, and you try to make sense of the two. And these are both representations of the same information, this table and this graph in the bottom left. Okay, we can also do stuff like sketching a graph based on a story. So let's take a look at this story. A model rocket rises quickly and then slows to a stop as its fuel burns out. It begins to fall quickly until its parachute opens, after which it falls slowly back to Earth. Sketch a graph that could represent the height of the rocket during its flight, and label the sections. So on a question like this, what they're asking you to do is just give an approximation of what the graph might look like of this object in flight. So the things we want to kind of take a look at the different sections of this word problem here, and then we're going to model our picture after the different sections. So the first thing we want to notice is that it rises quickly and then slows to a stop as its fuel burns out. Okay, so this rocket's going to launch up in the air and it's going to start to slow down, and then it's going to begin to fall quickly until its parachute opens. Once its parachute opens, it's going to fall slowly all the way back down to Earth. So there should be three sections to this graph. There should be this rocket rising quickly. There should kind of be as the fuel is burning out, and it's starting to fall, and then it should be the slow descent back down to Earth with the parachute. So things to remember down here, I have time. So as time moves on, going this way, okay, and then here's my height. So we know at the start, before we even launch our rocket, we're going to be here. Time 0, we're on the ground. And somewhere at the end over here, however long this is going to take, the thing's going to parachute all the way back down to the ground. So it's everything in the middle that we have to figure out. So what would it mean if this was to rise quickly? Well, if it rises quickly, could it go like this? That doesn't seem to make sense. The height's not going up very fast. A lot of time passed, so from here to here, a lot of time has passed, but from here to here, it didn't get a lot of height. So that's probably not going to be a good idea for that line. How about like this? So it's rising quickly, so maybe that took 10 seconds and it went a couple hundred feet in the air. So that would be rising quickly. And then it's going to slow to a stop. So it's rising quickly, and then the speed starts slowing down, slowing down, slowing down. And as the fuel burns out, it's slowing down, slowing down. It got a little bit higher, but then it starts to fall. It's going to fall kind of, actually, let's stop it. Stop our line here. So the fuel starts to burn out. It's not rising nearly as quickly until it gets to a point where there's no more fuel and it starts to fall. And it's falling quick like that, almost as quick as it was going up. And then what happens? The parachute opens, right? So here's my rocket, and its parachute opens. And what happens? It descends slowly back down to Earth. It just kind of drifts down over time and just drifts down to Earth. So here, the rocket's going up. Here's where it's kind of slowing down and running out of fuel. And then the parachute opens and it falls. So if I want to, We can just use words here too. We can say in this section, change the color here. In this section, the parachute is rising quickly. Then around here, this very top point is where it stops going up, right? Stops rising. Probably about the time that it ran out of fuel. This little section here is where it falls quickly. And this last whole piece here is when the parachute opens so it descends slowly. And that's it. So we can look at a word problem and we can sketch a graph. Notice there's nothing specific about the times or the heights. It's just how these two things are relating to each other. So if time moves quickly, or if time, however much time passes, the height needs to go up. If it's increasing, if it's going very fast and going up, then the height would have to rise much quicker than the time going by. And if it's falling slowly, then you have this second, or this last piece over here, where the height is decreasing slowly over a long period of time. Okay, for your homework in your notes, please take and match these words to rises slowly, constant, falls quickly. Take those words and try to match them to this graph. Let's call this height, and we'll call this time. So our two variables are height and time, and then just determine which sections, A, B, C, or D, have the following descriptions: rising slowly, stays constant, and falls quickly. Just label those in your notes and bring them in next class. We'll see you then.